very good afternoon and welcome to the last session of this course called Geoprocessing using Python. So till now we have discussed about the fundamentals of remote sensing GIS, then we discussed basics of Python. Then actually I think in the first lecture itself you were introduced to the two geospatial data models. One is called raster and another is called vector data. So now I think you must be you must be comfortable or must have got acquainted to the raster as well as vector data set. So actually vector data set, I just for the sake of completion, I will just go through like what is vector data, so that will make it complete. So as we discussed, as it was discussed in the first lecture, any feature on the Earth's surface, like you can say, this is the real world. So this real world can be represented in two models on in terms of in GIS parallels. Like either this entire surface on the this part of or this this uh, these features on the Earth's surface can maybe either represent can be represented either in the form of a grid of cells, or that is called raster, that what we discussed in detail in yesterday's lecture, or it can be represented as something called as vector or data with have data with discrete boundaries, right? Like here you can see that this these features like these mountains and all can be represented as maybe some polygons having discrete boundaries, or some part of it can be represented maybe using some points. So so the representation of feature on the Earth's surface may be in the forms of the objects which has discrete and clear boundaries is called vector data representation, right? So any feature on the Earth like this river we are able to represent it using some polygon, or the mountain tops, maybe these we are representing maybe as some points. So depending on the features of interest, so vector data is basically used for representing the features which has very clear distinct boundaries, and all objects are represented as these things, as three things we will discuss, like what called point, line and polygon. So it can say vector data represents objects on the Earth's surface using their latitude and longitude, or maybe a combination of these latitude and longitudes. We just represent the objects using their, you can say, their boundaries, right? Now there are different ways to represent. There are basically three ways to represent features on the Earth's surface. A feature on the Earth's surface can be maybe represented as a point. What is a point? Point is a pair of coordinates, like maybe say their latitude and longitude, that represents the location of the point on Earth's surface. Maybe when we are looking at a very small scale, at that time suppose we may say that we may represent an entire city using maybe as a point. But when we zoom in or make our scale larger, at that time maybe we may represent a wider, it may be represented as something called polygon, right? So whenever we want to represent something using a symbol thing like its location by latitude and longitude, that is called point representation. Maybe like suppose if we may want to represent location of some mailboxes, like these at these places the mailboxes are located, so that can be represented as a point data, or maybe some landmark buildings, right? So all these things can be represented as point data. Then the second representation is a line, a series of points that represent a line on the Earth's surface, like center of a road or center of a river, like a series of points. Those features or a linear features can be represented as lines. Then third representation is called polygon. Polygon is a series of points or vertices that define the outer edge of a region. Right, a series of points that define the outer edge of a region, but the series must be closed. Like the starting and ending point of the entire series must be same. So example, maybe we may represent the outline of cities, countries, or continents using something called polygons. So basically, any feature on this surface of Earth, depending on the scale, can maybe either maybe represented as a point, line, or polygon. So like this is a real example. You can say now suppose if you are interested in representing few features from this real world scene, right? So here you can see a linear feature called a river, right? So this entire river we can represent as a series of points, right? So this can be represented as a line. Like this road also can be represented as a line. So here we can represent this particular house, maybe represent we can represent as a polygon, delineating its footprint or building footprint of that can be represented as a polygon. And the trees here, we may, because we are not much interested in the details of the tree, so all the trees we can represent them as a point. Like this is here. So this way the features of our interest we can represent using vector data, because they have a clear distinct boundary and they can be represented either point, line or polygon depending on our application for what we are collecting the data. So plus these these any feature on the earth surface, this is about their geometry, like or location where they are stored. Apart from the location information line, location means where we can store what it is, like we can store some additional attribute or non-spatial data also we can attach to the vector data. Like suppose if we are representing every school in our area using point, like suppose we are just interested in their location only, then we can attach to those points some additional information, like what is the name of that school, what is the ID of that school, and how many students are studying in this school. Right here we have 3 or 4 schools represented as point, and we have stored their non-spatial or attribute information also we can store with the data. Similar way, now here suppose here we are representing some location of some bridges using some lines, then we have some attached information, non-spatial information also attached to that, like what is the name of that bridge and how much toll we need to pay for crossing that bridge. Similarly, like cities, for cities we have stored their boundary and some information about that city, like ID of the name of the city and who is the mayor at that city. And so this is all about vector data. So now we will discuss about one primary library called Pandas. So Pandas is basically an open source BSD licensed library that provides high performance, easy to use data structures and data analysis tool for the Python programming language. Basically, Pandas is apt in handling tabular data. So whenever you have tabular data, so Pandas is an excellent library for handling tabular data. So actually it is the advantage of Pandas over NumPy is that in Pandas actually we need to access any element by just numerical indexes. But in case of in case of NumPy, but in case of Pandas, we have labeled rows as well as labeled columns. So either row and label. Suppose if you want to access any data from any row and any label, we need not remember the integer indices. We can any row or column we can access with string indices as well. So that is the advantage of Pandas. So Pandas is a column-oriented data analysis Python library. It's a great tool for handling and analyzing tabular data. So in Pandas, basically there are two, actually as I said that Pandas is an excellent library for handling tabular data. So basically there are two core data structure in Pandas. One is called series. So series means in our entire table, any column, every column of our data is called a series. And when we combine more than one or more than one series together, that is our entire table, that is called a data frame. So our entire table is called a data frame in parallels of Pandas, and each column of that data frame is called a series. Now for installing, first before using the Pandas, we must first install Pandas in our, suppose if you have a local system, then you need to install Pandas, but in case of Google Colab, now it is coming pre-installed. So this is the simple convention for using Pandas. We must import Pandas as PD. Actually, you can call it any name, but it is a general convention. Anywhere you see Pandas being used, it is being referred as PD. Right, so Pandas, we are first importing these libraries, OS and Shapely, and we will discuss about Shapely later. Right now it is not needed, just Pandas is required. So even if I hash it, and then it must not have any effect. So it's connecting, now it got connected. So now let's see first how do we create a series. So for creating a series in Pandas, there is a function called pd.series. Like suppose now I just want to create a single column. So now later on we will create combine multiple columns to form an entire table. Even there can be a table with just a single column, but now first we are not creating an entire table. We are just creating a column. So for creating a series, there is a function called pd.series, and like np.array, similar to that pd.series, then you need to pass a list of values which you want to store in that particular column. Like here in pd.series, I just want to store the name of few districts of Uttarakhand state. Like pd.series, Dehradun, Almora, and Pithoragarh. If I say, and if I run, now you can see that a column will be created. Right now, this is how do we create a column. Now suppose if I want to create a table containing two columns, in the one column I will have city names, and in another column I just want to store their population. Right, so for that now we'll see how do we create a data frame. Like suppose I have created a column city names with by calling pd.series and passing them the name of districts, and in second column I am creating population, and in that I am attaching some fixtures population of these districts of Uttarakhand. How do we create a data frame? For that the function is called pandas.data frame. So pd.data frame, then it accepts, you need to give it as, actually there are multiple ways to do that. One of the ways, you need to pass them a dictionary. So in the dictionary what we are doing, we are, dictionary first is the name of the column. Like here we had just created few two pandas series or two columns, but we have not given them any name. Right, so here we are giving city name, give you so in pd.data frame we need to pass a dictionary. The key of the dictionary is the name of the columns which you want to create in your table, and value is the series. Right, so here we are creating the first column name as city name, and in that we are storing this column city names, and the second column we are giving it the name population, and in that storing the data of the population series. Now if I run this, you can see that a tabular structure got created here, like two columns city names and population, and with the populated data. So this way we can create a series and a data frame. Now let us see how do we read a CSV file using pandas. So actually I have stored all the data in a Google Drive, so I am just linking my Google Drive here. And so once this is done, now now the drive has already been mounted and it is visible. So now because the first I am changing my working directory to the directory where my data is stored. Inside this I have an India folder, and inside that I have all my data. So inside that I have a file with a CSV file called station underscore names.csv. In that file we have stored the location of different air quality monitoring stations across Uttarakhand. Right. So now let us see how do we read a CSV file using pandas, because sometimes you may get the data like this, and suppose if you want to convert it for visualization, then you can convert. So for because of that reason I am just demonstrating you first how do we read a CSV file. So I have stored a file name in a variable called file name, and suppose if you want to read a CSV file using pandas, the function for that is pd.read underscore CSV. pd.read underscore CSV, and you need to pass it the name of file which you want to read, because we have stored the name of file in the variable file underscore name. So once you read a file, and if you see df, then you can see that this is the entire detail of the file. Now this particular file, so easily you can read it using pandas, and in Jupyter Notebook you get a nice HTML representation of the file. So these are the columns in our file: station ID, station, name of station, then their latitude and longitude. And so the same file you can convert to a shape file or vector data file for representing it on a visualizing in a map. So now suppose if you call df.describe, so now once you go to a data frame as we said that it is a full table. So if you call df.describe, it gives the basic statistics about all the numerical columns in our file, because in our data frame now there are only two columns which has numerical data, latitude and longitude. Now it says it gives the statistics of all, like there are 152 counts or 150 rows in our table. Mean value of latitude is this, standard deviation minimum, 25th percentile, 50th percentile, 75th percentile, maximum value. So like this, by df.describe you get some basic statistics about the all columns which have numeric data in them. Now suppose this table is looking, this data looks quite big. Now suppose if you are interested only in inspecting some initial 5 values, maybe say, then you can call the function df.head. So if you call df.head, you will be getting this initial 5 rows. Now instead of 5, suppose if you want to inspect 10 rows, then we can call df.head and pass it the number 10. Similar way, suppose if you want to see the tailing 5 rows from your data frame, then tf.tail, then it fetches you the last 5. Then similar way, if you want last 10, you can pass the argument 10 and get the values. Once we have all these done, now suppose if you are interested in fetching only some individual column from that entire data frame, so then you can access it like this also, df, then inside square brackets the name, column name, which column you want to access. So suppose if we want to access station ID column, then you can call like this. And inside station ID also, again you want to refer to the third value, then df station ID, and the second index you can pass the row number which you want to access. So similar way, similar to numpy or string slicing, you can have slices as well. Then you can search for something like you want to check where station ID is equal to Nagthat or any number. So that you can write like a df, then in the square brackets df, whichever column you are looking for, df station, and equal to what value you want to look. Or then it will just fetch the row where the station name is Nagthat, right? Or anything you can put on. Even you can search for multiple values like df station in, then multiple things. Then suppose if you want to manipulate some data from that column, then you can write any mathematical expression, like suppose if you want to convert this latitude, want to multiply it by 60, then you can say df lat min, or anything, df the new name which you want to assign to the calculated value. Like here we have, what we are doing, we are df latitude column we are taking and multiplying every entry in that df latitude column by 60, and we are assigning those values into a new column called df lat in min, right? So this way you can do any kind of numerical calculation on the data. Now if you see df, a new column must got added with name lat in min. Lat in min, you can say that. Then similarly there are many more functions for this. Suppose if you want to sort the entire column using some a particular column, so you can call the function df.sort underscore values, and you can pass it an argument called by is equal to by which column you want to sort it. So this is all about pandas. So there is another library called GeoPandas, that is the extension of pandas for handling geospatial data. Pandas cannot handle geospatial data, so for that there is a library called GeoPandas. So this is, in this we will try. So there are counterparts of series and data frame in pandas to in GeoPandas. So series is geo series and data frame is geo data frame. So in this we will try to access reading vector data, manipulating vector data, doing some processing and writing back some vector data. So GeoPandas, as we said, is an open source project to make working with geospatial data in Python easier. Pandas extends the data type used by pandas to allow spatial operation on geometric types. So these are two basic data structures. Geoseries in turn may have point or multi-point, maybe line, multi-line, or polygon, or maybe multi-polygon. So as we said that geodata frame is then a geographical extension of data frame, which is a tabular data structure that contains a geoseries plus maybe some non-spatial attribute. The most common important property of geodata frame is that it usually has one geoseries column that holds a spatial status. So actually Pandas geodata frame can have multiple geoseries, but geoseries means geoseries contains the geometrical information, so that contains the geometries like maybe point, lines, or polygon. So then there are other, except geoseries, there are other columns that contains the non-spatial data. So a geoseries can have multiple columns. Means a geoseries can have multiple columns where you can store geometries, maybe line, points, or polygon. But out of these all geodata frames, one you need to select, which will be called the geometry of that particular geoseries. Now, what is the advantage of using geometry? Like suppose if you do some geometric calculation on that data, so then by default the calculation will be done based on the geometry column. So now let us see how do we read and write some popular vector data formats. So vector data, ESRI save file is the most popular non-topological format for storing and geolocation information, storing the geometric location attribute information of geometric attributes. So in ESRI save file, we can store the geometric location plus some attribute information about the any geographical feature which we are interested in. So the shapefile format defines the geometry and attributes of geographically referenced features in three or more files with specific file extensions. So one is called dot. So whenever you get a shapefile, you will have some associated 4 or 5 files with that file as well. So these are the extensions of these files. .shp is the main file that stores the feature geometry. So .shp file stores the feature geometry, maybe point, lines, or polygon. Then shx index file that stores the index of feature geometry. DBF, the database that stores the attribute information. Then there are other files called SBN and SBX. These files store the special index of the feature. Then PRJ file that stores the coordinate system information. So these all, at least 3 out of these 5, at least 3 files are required and 2 others are optional. So if you don't have, like if you are downloading something from the internet and if you are not getting all these files, then your software or even Python cannot read those .shp files. Then another popular format for storing vector data is GeoJSON. So GeoJSON is a format for encoding a variety of geographical data structures. A GeoJSON object library represents the region of a space, a spatially bounded entity or list of features, multi-polygon and geometry collection. Feature in GeoJSON contains geometry-based additional properties and feature collection contains this 0 features. This is how the GeoJSON data is stored. So here in the top level we have like type, what type of data we are storing. So whether it is a feature collection, raster or raster collection. So first we need to specify the type, and in the geometry we need to specify the geometry which we are interested in. Then some other properties like name and other things also can be stored as non-special data in the GeoJSON format also. Apart from these 2 languages, there are many other formats like GML or geography markup language, keyhole markup language, MongoDB, Microsoft SQL Server, special database, OGCWF services, and also there are multiple more more files, right? So now let us see how do we, till now we have seen how to read a CSV file. Now let us see how do we read a shape file. So anyway, first for using function of pandas, GeoPandas, we need to import GeoPandas. So we are just importing all the required packages here: GeoPandas, NumPy, Pandas, Mat, and from GeoPandas we are calling another called GeoSeries. So now I have here a data called state boundaries.shp, so which contains the state boundaries of all states of Uttarakhand. So suppose if you are interested in taking this data, this authentic data is all available on the Survey of India's website. So if you are interested, you can download these save files from the Survey of India's website. So vector file, in a variable called vector file I am storing this. Then in the India file I am storing the other data. GPD is not defined. So now you can see that if I type India, so type India, it says it is a geo data frame, and then if you want to carry the name of the geometry, which column is designated as geometry, it says that there is a column with name geometry that only has been set as the geometry of that column. Now, suppose if you want to, if you are interested in renaming some of the column, like geometry, you want to rename with something called borders, right? So then you can call a function your data frame dot rename and pass it column equal to your in the dictionary your old column name and new column comma column new column name. Then finally, if it is closed, then you can call dot set underscore geometry borders. With this, we are setting the geometry for our newly created column. Right, then if you search, just call india.head and india.plot. So this is then another. So here now you can see that the geometry column got replaced with the borders column. So similar way we can call create the figure canvas a bit bigger. So here you can see the all states of the India. So so now suppose if you want to it has been changed to borders, then we suppose if you want to plot this, then we can call the india.plot. As we said that the india.plot, and we pass it the figure size in what size we want to plot this figure. If we just call india.plot, it plots the figure. So as we said that our this particular geodata frame has one column that is called the geo series. So this geo series is now the borders column, which contains all the geometries of our shape. Now if I call india.plot, then it plots all the geometries which are contained in the geo series column of our data frame. Right, so this is quite easily. Now suppose if you want to change the figure size, you want to show it in the figure of 10 by 10. So we can plot in the shape and size. Right, now what happens when you download a shape file from any source? What happens with the shape file? You get many associated files as well, maybe like whatever we discussed like dot shp, shx, dbf, prj, shn, and other extensions. There is all auxiliary files we get with that. So generally what happens, we get the shape file in something called sbn and sbx. We got the shape file in a zip file, right? Now, so before reading this, if you are going to read these shape file in using some software or other thing, then you need to unzip those folders and then open the file in the software. But in case of GeoPandas, what happens actually, you can directly read a zip file also, right? So but only thing that for that, see all this data I have stored in my Google Drive. Inside this my drive I have data and India. So inside this I have this administrative boundaries underscore database dot zip folder. So in that zip folder there are multiple shape files available inside there. So suppose if I want to read directly, directly from a zip file without unzipping, so that I just want the GeoPanda itself to unzip the folder and extract some particular shape file from that. So then only thing I need to specify here my file name a bit differently. Like, so whenever I am reading a zip file, I need to specify the file name just by using this zip : /. So if I specify like this, then I can directly read a zip file from the GeoPandas. So zip : and administrative boundary database dot zip. Now suppose inside this zip file, I assume that there are many other shape files, right? So then then I need to specify exclamatory mark and the name of the shape file which I am interested in reading, like this major towns dot zip. So directly this way I can read a shape file from a zip folder itself. Now if I'll call, now reading for that, the function is same, geopandas dot read underscore file, the name of your file. And if I call it has been read, now this has become a geo data frame. Now I just want to query it. Then I say that I have read the major towns. Right. Now suppose if I want to plot this, so same functions like just by calling our data frame dot plot, and inside that I can specify there are many more options. So the basic option which I can is I am passing here the size. So 18 by 14 I am saying. So if I call India dot plot, so it will be showing the all major towns. Actually these are very densely populated towns. Now you can see that this is the towns and these are their non-spatial attributes of these towns, like maybe rotation scale, name of the town, in which district it is, and what is the state and what is the elevation. So these all data might not have been stored properly, like Sukhani, Kishanganj in Bihar, Kanki, Kishanganj in Bihar. So these are the all major towns of our India, and these are their non-spatial attributes, maybe like their names and their location and what is their elevation. And this is the plot of these. So once this is done, we can call it. Now second thing is now like suppose this is our entire India's data frame. Now suppose if we want to subset this data, suppose we are interested in only we are interested only in some particular state. Suppose if I want to extract data or the major towns of Uttarakhand state only. So then like as we discussed in the pandas, how do we subset or filter frames? So like here we can, because there is a column here, name of state, like state column is there. So I can filter it like my data frame name, then inside square brackets I can say India and which column I am looking for. Inside India I am looking for state column. Wherever the column's value is equal to Uttarakhand, just filter out those rows. So those are rows I am storing in something called subset. Now if I see subset dot head or subset at large, so now you can see that only thing the entries are only with state Uttarakhand. Right now if I just plot it, I'll be seeing the points which are lying in the Uttarakhand state. So by seeing this latitude and longitude, anyway by this you cannot make out. When we will explore it, then if I say subset dot explore, so there is a function called subset dot explore. Now if I now suppose if you want to explore them in a OpenStreetMap, so it says we need to specify map classify I need to install. Okay, in the later part of the code it is there. We will, so they are now actually, these are the only states of the these are the major towns of the Uttarakhand state. So later on we will see how do we see them on a OSM map. So this is already done, and this is just changing the figure size. So by figure size you can change the figure size. Now this is there. So actually for using this we need to install another library called map classify. That is not coming by default in a Google Colab. So as we have discussed that any additional library we can either store by using conda, suppose if you have local installation, and if it is available through pip, then in the Google Colab notebook itself it will specify something with the exclamatory mark. So what it means that that particular thing, whatever is following this exclamatory mark, is a system command. So this is a pandas command. So if I write pip install map classify, it installed the map classify library in my system. Now I'll just clear all output where I was. So after specifying, now suppose if I want to explore this subset on like these points, whatever we have filtered out on something called a OSM map, then we can call subset that explore and by what to color these points. So directly you can see these points on a OpenStreetMap. So this way we can say that initially we filtered only the major towns of Uttarakhand state, and now suppose if I want to visualize them on actual OSM map, so this way I can, by just calling our data frame dot explore, only thing that we need just to install the map classify library in our system, and if you call map dot explore, then directly we can see these all cities on our map. Now if you click on any point, you will see the non-spatial attributes of that point. Like these all cities were stored as if you hover around these points, you will get the non-spatial like rotation, scale, name of the town, district, state, and elevation stored in that. Right. So this way, it's just by writing a few lines of code, you can make such good visualizations. Right. Similar way, you can filter. Anyways, we have done already these points. Then similar way, because geopandas, their vector, as we have discussed that vector data also comes in multiple formats. So geopandas also can read many of these formats. Suppose now if you have data available in GeoJSON format, so in my folder I have the map of India in GeoJSON format. Also suppose if I want to read that, I will specify, and the function is same for reading either if you want to read a save file or maybe GeoJSON file. The function is same gpd.read underscore file, and you pass on. Then you can read the GeoJSON file as well. Now you can see. So this way we can read a shape file. Now suppose if you want to write a shape file. Now suppose you have some data in a CSV format and you convert it into maybe some, you added some geometry column to your pandas series, and suppose if you want to write it back. Right, now let's see how do we write a shape file. So now anyway we are reading the same file first from the administrative boundary database.zip. Now I am reading the boundary district boundaries of India.shp. So that file, from this file I am just filtering out the district boundaries of Uttarakhand state by calling this UK India state is equal to Uttarakhand. If I say UK, and if I say UK.plot, so from out all these district boundaries dot shape file, I have just extracted the boundaries of Uttarakhand, districts of Uttarakhand. Right. So this way, now suppose if I want to write just this data to a shape file. Now I have Uttarakhand.shp. So if something is there, I will delete. So now you can say that there are already some Uttarakhand.shp files. I will be deleting those all files. Right, now all the data we have available in the UK data frame. Now suppose if I want to write this, then the function is like for reading a file, there was function data gpd.read underscore file. Now suppose if I want to write a geodata frame to a shape file, then I can specify my data frame name. In that there is a function called to underscore file. Then I will say that I pass it the name of file in which I want to write the data. So I'll say uk.to underscore file. Shape file. It says that field shape area is not successfully written, possibly due to number width. So I think out of these attributes, one attribute it was not able to write, and it has specified some reason due to the large number within or something. You can read about this. So now once I see this, refresh it. Now you can see that I must have. So now you can see that these all files got created: Uttarakhand.cpg, dbf, prj, shp, and shx. So just by calling dot to underscore file, we can write a geodata frame. And now you can open these files with say maybe pandas or any other software as well. Similar way, now suppose if you want to write this particular geodata frame in the GeoJSON format, then only thing you need to specify like your data frame dot to underscore file and the name of file as some with an GeoJSON extension, and only you need to pass second argument to underscore file is the driver. Like in GDAL there were different drivers for different formats. So similar way in GeoPandas also had different drivers for different formats. So suppose if I want to write a GeoJSON file, then I need to pass the driver is equal to GeoJSON. By default, what happens? By default, the driver is ESRI shapefile. So now because now I want to create use a different kind of driver, so I will pass in second argument driver is equal to GeoJSON. With this, I can write a file with GeoJSON format as well. And similar GeoJSON file, suppose if I want to read it back, I can read like read file, and now I can see, and if I plot this, it must be shown like this. So anyway, there was some problem I think with this. We will not go to the detail plot. So now let us see how do we manage projections. Right, as we have discussed, there are two projections, geographic coordinate system and maybe some projected coordinate system. So with every file we have a CRS, a coordinate reference system, describes how coordinates in a geospatial dataset relate to location on the surface of Earth. Right, a geographic CRS consists like suppose if these the location of the points is stored as some numbers, right, maybe 3.5 or 30.5. So what does that 3.5 or 30.5 represents? Whether this is latitude or longitude in degrees, or maybe it is a projected latitude projected location, maybe in UTM or something, right? So for knowing that, we must attach with the geodata frame a CRS information, right? So it can be stored in it can be a geographic CRS, a 3D model of the shape of Earth approximated and approximated as a sphere or spheroid. So this will be in decimal degrees or meters. Like then it can be a projected coordinate system, also maybe a UTM or other kind of projected coordinate system. So in GeoPanda, suppose if you with your shape file, suppose if you want to specify your coordinate system. So there are multiple ways you can specify the coordinate system. You can attach coordinate system to your shape file. One, either you can specify in something called PROJ4 string. So this will be specified like PROJ is equal to long lat plus ellipsoid, datum, and some other things. Or you can specify it directly by using its EPSG code also. So suppose now you want to identify what is the CRS. So you want to check what CRS, in which CRS my data is stored. So here let us see, we are reading specifying the vector file, and we are reading the file in the data frame called geodata frame, and you can call the function attribute. Actually the CRS is stored in something called attribute called CRS. Now suppose if you want to query what is the CRS associated with this particular save file or geodata frame, then you can call like india.crs. If I call it, prints the information about the coordinate system. So it says this particular data frame has the projected CRS LCC WGS84. So this name is LCC WGS84. So east and north in meter, easting and northing in meters, and these are the details about this particular CRS. Now suppose if you want to change the CRS of that, like by calling your data frame.crs, you query the CRS, and suppose if you want to change, you can like you can assign a new coordinate system to this, like india.crs is equal to none. If you write, it will become none. Now if you are changing to none, so now it will become unprojected. India.crs, now it shows none. Now suppose similar way, suppose if you want to reproject, suppose you have data in geographic coordinate system and you want to convert it to projected coordinate system. Let us see how do we convert or reproject a shape file. So now here I am just reading the file, and I am querying its CRS. It said it's a projected CRS LCC WGS84. Now suppose if I want to reproject it to maybe something called web marketer projection or projection with code EPSG 3857. So for that, for reprojecting a file in GeoPanda, there is a simple function called to_CRS. So this will reproject your file to the new projected coordinate, new new CRS. Like suppose here I want to reproject this particular file to a projection system called EPSG 3857. So I can just call india.2 underscore CRS EPSG 3857, and I'm storing in the new variable called India reprojected. So this way we can reproject. Now suppose if we plot them both together, so you can say that this was our original file in LCC WGS 84 projection. So now here you can see the numbers let long or coordinates are in very huge numbers. So these are in meter, and but and these are also in meter, but this is Mercator projection and this is LCC projection. So by calling just 2 underscore CRS, you can reproject your image. Now let us see how do we create some maps with pandas. Like we have these attribute data, and now suppose if from this data, suppose if you want to create some choroplast map or maybe some classification map and something like this, suppose if you want to create or map this. So so why actually GeoPandas provides a high level interface to the something to the library. So actually as yesterday we had used different functions, so like one IMShow function of the matplotlib library. So what happens in case of GeoPandas provides a top high level abstraction for these libraries. So ultimately on the back end GeoPandas also using matplotlib, but as a user or a developer we need not access directly matplotlib. So GeoPandas itself provides a high level interface to the GeoPandas, and automatically it calls matplotlib with required arguments itself. We have just on geo data frame, as we have seen that we need to just call dot plot function on the geo data frame itself, and internally it takes care of calling uh, all the respected functions of the matplotlib function. So we need not worry about that. Now here I am reading the same file, India shape files, and if I call india.head, so is now suppose if I want to plot, by default it will be, it was showing, it was filling the with them with the blue color. Now suppose if you want to change the color of all those polygons, then I can pass to this plot function and another argument called color. So in that color I can specify in which color I want to it to be colored. So I'll say color equal to green. So in that case all the polygons will be filled with the green color. Now suppose then I can specify other colors like edge color, face color also. I can specify edge color equal to red and face color is equal to red. And similarly now I can say face color none also I can specify, and I can say them to be red. So this way you can just plot the outer lines, outer, and also maybe green. So this way you can pass other arguments to this depending on how do you want to visualize your map. Right. So now suppose if you want to create a choroplast map. So GeoPanda makes it very easy to create a choroplast map. So map where the color of each shape. Now here we can see that all the shapes were drawn in the same color. Now suppose if you want to see the color of the shape to be drawn according to some attribute. Right. Now suppose if you want to color these polygons or these state or district boundaries by the color of the using the population, like the depending we want to color them based on the population attribute of these polygons. So for that again we can specify, like function is same, our geodata frame dot plot, and on which column we want to color them, like column shape area. Now suppose if you want to give them color based on the how much area each polygon has. So I'll call column equal to shape underscore area. Now you can see that all these polygons have been colored in different colors. So depending on what area is contained in these, like how much area these polygons cover, now you can see that it shows these all with the same color. So roughly they have similar area. So because of that these all have same color. Now there is no legend attached to it. Now you don't know what number does what shape area these color represent. Now suppose if you want to attach a legend to this, then you can specify another column legend equal to true. It attaches a legend with that. So this is the legend. So similar way you can change the orientation of this and other thing, label, orientation and all you can specify with this. Now similar, this might have used some default color map. Now suppose if you want to change the, now suppose if you wish to change the color map used for coloring these polygons, then you can specify another argument to this plot function called CMap. Like there are different color maps, you can specify them like these are the name of all the color maps, or these are the classification scheme actually. Then you can specify the color map. Now it will use different color map for the choropleth map. Then you can specify the classification scheme for these numbers like these. Now these may be equal interval. So these are the different classification schemes, how these numbers will be classified. In suppose our population is from 0 to 10,000. Now we can classify those population maybe in equal interval, natural break, or anything for better for making different classes for this. Like these are the different how the numbers are broken, like natural break, quantiles, equal interval, and on. So you can specify here your data frame dot plot and column, and you can specify a scheme for classifying the range of the numbers. So maybe suppose we have specified natural break. So now you will see that the color scheme changes. Right. So this color represents population from this range to this range. This this color represents population from this range to this range. This way, or this is not population. This is the shape area. So this way you can now you can see that the colors got changed. Now these all maps were a single layer map. Now suppose if you want to create a suppose if you wish to make a multi-layer map, like these all layers were single layers. Now suppose if you want to have, if you have the state boundaries on the top of that, suppose if you want to show the state capital as a point layer. Suppose if you want to create a multi-layer map using GeoPanda, let us see how do we create a multi-layer map. So in this I have a file called state boundaries, and second layer I have state headquarters dot shape. So now I will just read those files in two data frames. So the first file India geodata frame has the boundaries of all the states, and state headquarters has the boundaries of all state headquarters. So now I just, if I call this, now I can see this is the CRS. So actually whenever you are, or whenever we are making a multi-layered map, so first thing what we need to ensure before making the maps, that the projection or CRS of the both of the layers which we want to project on the top of each other must have the same CRS. If the CRS of both of them is different, then all the boundaries or geometries will be misplaced. So you may not find them to be located correctly. So before creating a multi-layered map, you must ensure that the layers which you are stacking on the top of each other have the same CRS. Like so, we are just first inspecting whether we are checking that whether these India data frame and state headquarters data frame, do they have same CRS. So now I'll say state headquarters dot CRS. So now both of them have the same LCC WGS84. So because now both of them have the same CRS, now we can create a multi-layered map. So for that, first, as we have discussed yesterday, we discussed about subplots. So now there is this another function called subplots. So I'll call plt.subplots. With that, I'm creating a figure and axis. So in that now I am calling India.plot and state headquarters.plot. So in that I am passing two arguments like axis. So axis is this axis which we have created here. If we pass them here and run this way, we can create a map. So here you can see that we have created a multi-layered map. So outer layer is the base layer is the state boundaries, and on the top we have their headquarters. So right, this way we can create a multi-layered map. So with this, so then you can suppose if you want to do some other analysis on this data, suppose we have suppose then on these geometries we can create other attributes. Suppose if you want to create a convex hull, or suppose you want to represent the smallest representation a polygon containing all the points in that object unless the number of points in the object is less than 3. Suppose if you want to create it, so convex hull, suppose if you want to create the convex hull for our entire geometry, so convex hull represents returns a representation of the smallest convex polygon. So it is an smallest convex polygon representation of the all the points in the object, right? Suppose if you want to create the convex hull inside the our, right, then you can call our data frame dot convex hull, and if we just plot it, convex hull dot plot, so this way we can see that this is the smallest convex polygon representation of our boundary. Then similar way we have functions for, suppose if you want to create an envelope around our entire boundary, then you can call dot envelope function, and if you call env dot plot, we can create an envelope around our geometries. And suppose if you want to create some simplified representation of our geometries, then we can call the function geo our data frame dot simplify and some error margin, and you can pass another argument called preserve topology, true or false. Then this simplified representation dot plot, if you call, then we can create a simplified representation of all the geometries inside our geodata frame. So with that we come to the end of this lecture. So with this, if you have any questions, you are welcome. Please, you are welcome to post them on the chat box. So I will try to answer all of these questions. So we will be back after 5 minutes. Thank you very much.